Welcome to Summarize Science. Today we are looking at an exciting development in the world of robotics called DexJoCo. Most robots you see today use simple grippers that act like pincers, which severely limits what they can actually do in a human environment. The researchers behind this paper argue that for robots to truly help us, they need dexterous hands with multiple fingers that can mimic human movement. DexJoCo is a new project that provides a benchmark and a toolkit to test how well AI can control these complex robotic hands. It focuses on task-oriented movements rather than just picking up and dropping objects. To train these systems, the team developed a low-cost way to capture human hand movements accurately. They used special smart gloves and motion trackers to record over 1,000 human demonstrations across various tasks. This setup allows the system to learn from the way a real person uses their fingers to manipulate objects. These recorded human movements are then translated into instructions that a robotic hand can understand in a physics simulation. The system uses a specific algorithm to make sure the robot's fingers move naturally and avoid colliding with each other. This avoids the jerky or impossible movements often seen in older robotic simulations. The benchmark includes 11 different tasks that test various skills like using tools and coordinating two hands at once. Some of these tasks include watering a plant, unfolding a pair of glasses, and even using a computer mouse correctly. Another task involves using tongs to pick up objects, which requires very precise pressure control. In more advanced, long-horizon tasks, robots have to perform a sequence of actions in a specific order. For instance, they must open a microwave door, place food inside, and then press the start button. Bimanual tasks are also included because they are especially difficult for AI to master. These require the robot to use both hands together, like holding a tray with one hand while inserting a peg with the other. To make sure the AI is robust and not just memorizing one scenario, the researchers use domain randomization. This means the simulation constantly changes things like the table height and the lighting direction. They even swap out the textures on the table and objects to see if the robot's vision can still figure out what to do. Interestingly, the study found that current AI models still have a lot of room for improvement. The results showed that while robots could often pick up a tool, they sometimes forgot to actually use it or release it correctly. In the microwave task, a robot might put the food in but then accidentally pull it back out when withdrawing its hand. They also tested if the robots could follow language instructions like, unlock the device. It turns out that even advanced AI models sometimes default to a fixed behavior instead of truly understanding the command. The robots often struggled to click the correct button even when they were in the right position. One major takeaway is that current AI models are mostly trained on simple grippers, which creates a mismatch for complex hands. The research emphasizes that we need better models specifically designed for high-dimensional hand movements. They suggest that adding touch sensors to the fingers might be the key to achieving better precision. Let's recap the most important points from the DexJoCo project. It provides a standardized way to measure how well robots can handle complex, human-like tasks. The data shows that while we have the hardware, the AI brains still need to develop better coordination and memory. In the future, this research could lead to robots that can help with delicate chores or assist in a workshop with ease. By bridging the gap between human motion and machine control, we are moving toward a world where robots are truly capable assistants. Thank you for watching Summarize Science.